In this lesson, we're going to talk about maybe the most important concept for grade 11. At least it's the introduction to the most important concept. This entire unit is on what a quadratic function is. We talked about a quadratic equation last unit. In the quadratic equation, you always had y equals 0, and you solved for that equation. A function has both the y and the x in it. And this tells you that this is going to be something that we can graph. Okay, so what is a quadratic function? A quadratic function is any function that can be written of the form y equals ax squared plus bx plus c. Note there has to be an x squared in there. Okay, this is called the general form of the quadratic function if it looks like this. Okay, so let's get out Desmos. And you should be trying this on your own, but I'm going to graph these for you pretty quickly. What does the graph y equals x squared look like? Well, you can use Desmos to do this, but I'm going to also show you a quick little trick with table of values. If you remember when you did a table of values, you always chose these values, and then you found out what y was. Okay, if I do that, here are some of the points that I get. I get a point 0, 0. I'm going to get a point 1, 1. I'm going to get a point 2, 4. And it's symmetrical on the other side. I'm going to get the same points over here. And this graph, oops, that doesn't look too good. This graph that is made with these points is called a parabola. Okay, if we want to just write that here, this is called a parabola. Any graph with an x squared is going to have this basic shape. Okay, and I would get pretty comfortable drawing a basic parabola. You should have, there's a lot of things you note here. Notice that it's symmetrical. Notice the shape. Notice some of the points that were plotted there. Okay. We're going to get pretty good at this because you're going to do a lot of graphing, a lot of this shape. Alright, if I do this one with a negative x squared, that's just going to turn all of the values negative. And for now, because you can use Desmos, just take my word for it that it's going to just turn it upside down like this. Okay, and what are these points now? Well, the x is 1. The y becomes negative 1. When x was 2, the y becomes negative 4. Okay, and we could keep going here with this graph. This one is going to look something like this, I think. You can try Desmos with it. This one's going to be, let's just see here. It's going to have... I think it's something like this. Okay, go ahead and try those, but those are the basic parabolas. Use Desmos to try it, and then this unit we're going to learn how to do that without Desmos. Okay, so let's take a look at some of the characteristics or properties of a parabola. Okay, first of all, there's the vertex. The vertex is the point where the parabola turns around. So if you remember the ones we had on the previous page, the vertex would be this point where it's turning around, okay, where it goes and seems to change direction. Okay, domain, we know about this. Domain is all the x values, range is all the y values. The axis of symmetry, this is the line that passes through the vertex. It's a vertical line. And remember how I said that the parabola is symmetrical? It should be identical on both sides of these lines of symmetry. Okay, the graph will look exactly the same. Okay, the zeros, x-intercepts, or roots. Hey, get used to this. 3 ways of saying basically the same thing. Okay, these are where it crosses the x-axis. Okay, the y-intercept where it crosses the y-axis, and then the graph will either have a maximum. Okay, if it looks like this, it's going to have a maximum point, or a minimum. If it looks like this, it's going to have a minimum point. Okay, so let's try a graph and see if we can find these characteristics. So first of all, we're supposed to find a vertex. We're going to do the domain and the range. We're going to find the axis of symmetry. We're going to find the x-intercepts, or the zeros, or the roots, whatever you want to call them. The y-intercept. And then we're going to say, does this have a max or a min? Okay, those are the characteristics that were listed. So in this picture, what is the vertex? The vertex is right here. It is 1, -4. What is the domain? Okay, here's a great little tip for you. In a parabola, the domain will always be -infinity to infinity. This is going to be a free mark. When I ask you on a test, you're going to kind of chuckle to yourself and go, ha ha, I know this. It's -infinity to infinity. Okay, because it's going in both directions forever. So all the x values are included. What is the range? Well, the range is the y values. So we're looking this way. Well, you can see there is a minimum value of -4, and it goes all the way up to infinity because the arrows keep going up. Okay, the axis of symmetry. This is the vertical line that goes through the vertex. Okay, and that should always be written as an equation. So x is +1. What are the x-intercepts? These are the zeros, the places where it crosses the x-axis. Looks like it's -1 and 3. The y-intercept is where it crosses the y-axis. That's a -3. And does this have a minimum or a maximum? It has a minimum point of y equals -4. Okay, so that's your parabola and some of its characteristics. Now, can I get you to do the same thing for this one? So, pause the video and see if you can fill out these characteristics. So the vertex is 3, 0. The domain, should be chuckling to yourself, you know that. What is the range? Well, the range starts at -infinity and goes all the way up to 0. Okay, so you can see it goes forever this way, and it stops right here. Axis of symmetry. That's x equals 3. Notice I'm writing it as an equation. Should always be an equation. The x-intercept, where does it cross the x-axis? Only in one place, at 3. The y-intercept is -18. And this one has a maximum, and the maximum is y equals 0. Okay, so pretty easy looking at a graph like that and writing the characteristics. What you're going to be expected to do is do the same things given an equation. Okay, so by the time we're done this unit, you're not going to need a table of values, but for today, we're going to use a table of values. So we're going to pick some values here for x, and let's calculate what is y. So if x is -2, you're going to get -6. Okay, let's try -1. If I put -1 in here, I'm going to get 2 minus 4 minus 6. So that's going to be -8. Okay. If I get 0, that's going to be -6. If I put in a 1, it's going to be 0. If I put in a 2, I get 8 plus 8. Okay, so let's plot these points. -2, -6, -1, -8, 0, -6, 1, 0, and 2. Well, that's going to be off the chart here. Okay, and so now we want to try to graph this. Now I can see this part. Okay, and I'm going to want to go all the way up to here. So let's try to draw that a little bit better. Okay, and now what happens after that? Well, remember that the parabola is symmetrical, so I know that this point here is going to be symmetrical about the axis of symmetry. So it should be right over here. Okay, so that should help you with some of these drawings. Okay. So this is good enough. There's our parabola. Okay, now what is, or what are the x-intercepts? Well, we just happen to have them written there. They are -3 and +1. The y-intercept happens to be one of the points we found as well. It was -6. So that's kind of nice. Now that's not always going to happen. We'll get into what happens if you don't have them written later. Coordinates of the vertex. Well, I can see the vertex is -1, -8. Again, you're not always going to see them on the graph. You might have to find them. We'll talk about that as well. This is going to be x is -1. The domain, -infinity to infinity. The range is going to be from -8 to infinity. And this has a minimum point of y is -8. Okay?
Grade 9, you're welcome to transition to your C-slot class.
Okay, let's try another one here. This one looks a little bit trickier. I see fractions. That's going to make it hard. Now, we can't just multiply everything by 4 because then you'd end up with a 4y. So that's not a strategy we can use here. We will use these same basic points, and this math is going to be a little trickier. So we'll put a -2 into the x squared. That'll give us 4, and then if I multiply by -1/4, that should give me -1. If I put in a -1, oops, that's not correct, sorry. It'll be -1, -2, 3. I think this gives you 6. Sorry, not 6, it's 10. Let's do this one actually. We'll actually do the math here so you can see. So I have -1/4 times -1 squared minus -1 plus 9. So this is going to be -1/4 plus 1 plus 9. So that's going to be 10 minus 1/4. So that's 9 3/4. If I put in a 0, I'm going to get 9. Okay, and if I put in a 1, I'll get -1/4 minus 1. So that's -1 1/4 plus 9, so that's going to give me 7 3/4. And if I put in a 2, I'm going to get -1, I'll get 6. Now if you notice those points, I'll quickly plot them here. -2, 10, 9 3/4, 9, 7 3/4 is going to be about here. And then 6. You can see I don't have a turning point of the graph. I just have this part. So maybe I need to put one more point in there. Let's put a -3 in there because I want to go somewhere over here and figure out what's happened. If I put a -3, I'm going to get -9/4. Let's actually try this. Y is -1 times -3 squared. Take away -3 plus 9. So this is going to be 9/4. So that's 2 1/4. Oh, it gives me 9 3/4. So there you can see that I'm coming back down. Okay, so then I know that this is my vertex. Okay, so we'll just kind of make a messy graph like that. Don't worry about it for now. What are the intercepts? I have no idea. Okay, so this is one where you're going to have to do the math. Now, how do you find an x-intercept? You find the x-intercept by making y equals 0. Alright, so we'll write 0 is negative 1/4 x squared minus x plus 9. Now, does that look familiar to you? It should. This is what you spent the entire last unit doing. Remember, we had 4 ways to solve an equation. We had factoring, we had perfect squares, we had the quadratic formula, and we had complete the square. Okay, those were the methods we had to solve equations. Well, this is an equation. It's x squared equals 0. So we should be able to solve this. Let's try by factoring. I'm going to multiply everything by 4. So I get this. And now I would like to see if I can factor that. Okay, I'm going to divide by negative 1 just to get me a positive. So x squared plus 4x minus 36. And now, wouldn't it be great if this factors? It doesn't look like it does. How do I know? Well, let's do b squared minus 4ac. 4 squared minus 4 times 1 times negative 36. This is 16 plus 124, which is 140. This is not a perfect square, which means I cannot factor. Cannot be factored. So what in the world am I supposed to do? Well, since I can't factor it, I'm going to use the quadratic formula. Okay, and so then you would find the quadratic formula. Now, that's how we go through a question like this. Normally, that's not going to happen. They're going to be much simpler. Okay, but somehow we could figure out what those two x-intercepts are. We'll talk about that for the rest of the unit. That's what we'll be doing. Okay, the good news is the y-intercept is easy. The y-intercept is 9. How do I know that? Well, if I go up to the equation and make x be 0, I end up with just 9 left over. Okay, coordinates of the vertex, figured that out. That was negative 2, 10. Equation of the axis of symmetry, x is negative 2. The domain, negative infinity to infinity. The range, negative infinity to 10. And this one has a maximum. Alright, so normally those things are really easy to find. The x-intercept is going to be the trickiest thing, and that's why we spent the entire last unit trying to figure out how to solve equations, because that's what you're doing when you're finding the x-intercepts. Okay, so we'll try one more here. Oh, that should be t here, so that we have just one, not t and x. So this one is looking at an application of a quadratic formula. Think about this. If you throw something into the air, it's going to do this, right? It's going to start at the ground, go back, and hit the ground. That's the shape it makes. Whether it's a football going, whether it's a rocket shooting into the air, whatever it is, it's going to make that kind of a shape. Okay? And what we want to do is look at it more specifically. So let's make a graph here. Okay, now the other graphs I did, I used a Cartesian plane like that. Why am I not going to use a Cartesian plane? Why am I not caring about what's down here? Well, that variable is height. You can't have something go into a negative height, because that would mean it would go into the ground. Okay? So, it says to use technology to graph this. I'm going to do a quick sketch. I can see the y-intercept is 10. and I can see that it has a negative in front of it, so I know it's going to be a parabola that looks something like this. I don't know what these values are, but I can probably find them. Okay? So there's my graph. Let's identify and explain the significance of the intercepts. Well, what is the y-intercept? The y-intercept is where x is 0. In this case, where time is 0. Where is time 0? That's at the start. That's when this thing was launched. It must have been at 10 meters. So when time is 0, the projectile was 10 meters high. So a launching platform or something. Okay, what about the vertex? Well, we don't know how to find the vertex yet. I'm going to teach you how to do that, but the vertex is right here. I just don't know where that happened. I don't know what that time is and what that highest value is. Okay, so we're going to talk about that. If you use Desmos, okay, if you use Desmos, it would be pretty easy to find. You would just put it into the equation. You could tap it, tell you what it is. And then we have the x-intercepts. How do you find the x-intercept? You would make h equals 0. So you'd have 0 equals negative 4.9 t squared plus 50t plus 10. Okay, and I can tell you this one's not factorable. You would use quadratic formula. Again, most of the time they're going to be factored. It should be pretty easy for you to find them. Okay, so I have some homework for you to try here. I would like you to do this. If you have questions about it, please ask. We're going to get into much more detail with the quadratics next class.